Hi students, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody let me know in the chat box if I'm clearly visible and audible to you and how are you all, right? I saw you guys commenting on the last video and I'm very happy about it that you are doing your homework, right? That nothing can be better than that, right? If I'm giving you some homework and you are actually putting in efforts to do that and you are putting the comment over there, don't feel that I don't see your comments. I definitely see your comments, and I will also put all the comments here, those students who have done the homework, right? Okay. Yes, everybody. Hello, Ibu, Rehan, GV, Vignesh, Alan, Visuki, Cupcake Frolic, Chemistry Catalyst. Yes. Rehan, Siddhi, Dakshina, hello, hi everybody. So, let me introduce myself to all the students who are new here. I'm Diksha Kaushal, your chemistry master teacher. I'm going to teach you here chemistry for JEE Mains and JEE Advanced, and I'm MSc, BSc in chemistry with B.Ed, and I have 8+ years of experience, right? So that's about me, right? And I would also like to know about you guys, like whether you are like dropper or you're in class 12, because depending upon the audience, I keep coming up with some videos that are actually useful to the students of 2026, 2027. And that too, if I talk about 2026, those students who are droppers and those students who are in class 12, they have different uh, you know, different things that they are suffering, that they are going through, right? So to take that, like to make that okay for you, right? I come up with different videos, right, to sort things out for you. But I try my best. Before that, I also want to know, like in yesterday's video, I saw one student writing down that, ma'am, I want Solomon's and JD Lee, what are the topics that we should study from there. So definitely I'll come up with the video like that, right? Okay, so don't worry. I definitely watch all your comments, right? Yes. Okay, so awesome. 12 complete. Awesome. Okay. So, and before going further, let me tell to all the students here who are preparing for JEE 2026, right, students, as you can see this, right, this is our results of JEE 2025, right? You can see AIR 15 here, right, 120 of 120 in maths, and you can see the other aspirants as well, right? If you want to be one of them, right, and you want to have a scholarship here, then students, we have this IVSAT scholarship program for you, in which you need to register yourself, right? And after registration, you can give the test offline or online. I would advise you to give the test offline. And after that, what will happen? According to the marks, right, you will be provided with the scholarship. And you can avail up to 90% scholarship here. So that is an amazing opportunity for you. So I would advise you to grab that opportunity. And if you're still confused that and you're living nearby Karnataka, right, living in Bangalore, then students, this is our JP Nagar Bangalore offline center. You can just click, this is the phone number here, right? If you're confused about the offline admission, you're confused about the IVSAT scholarship program, just click here, they just call on this number and tell that I'm a student of Vedantu JEE English, and the help will definitely be provided to you, right? And this is the address. You can also go and visit, meet the counselors, right? You can meet the teachers, right? All the guidance that you need to do, you can have that, right? And we are also providing you rank improvement guarantee. If it is not there, 100% fees refund will be there. This is especially for the repeaters or the droppers, right? So that is a very rare guarantee that any institute provide. This we are providing only because we have confidence on our teachers, we have confidence on our education, that what we provide you is worth for your JEE coaching, right? And if you're looking for, like, ma'am, I am not staying in Karnataka, I am from some other city and I'm from some other state, then students, you can see this is the list of Vedantu learning centers, Vedantu offline centers, right, nearby you. Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, and Uttar Pradesh. Okay, so you can look for which is very near to you. You can visit your nearby offline center, or you can call and you can meet your teachers and counselors. And I would advise you to give the IVSAT scholarship in the offline, okay, so that you also get an idea what kind of classrooms are there, what kind of teachers are there, what kind of future, like 1 or 2 years are going to be in that institute, right? So that will help you to decide, right? Okay, yes, everybody, awesome, awesome, awesome. So let us see the shining stars of last session, right? And who is going to see, like out of you, whosoever see their name right over here, I would like to see green hearts, or I would say blue hearts from those students, right, who will see their name here. First is Thala. Okay, so that is first and second answer done. Then Arun, then you have Regi, then you have Unhuman. Like names you give now, that is like next level names, right? So Kevin, very good. So all these students have done their homework. Sai, Arjun, Gopi, Shagun, awesome. Then you have Pragna, Vignesh, Dheeraj. Okay, okay, great, great, great. So all the students who have done their homework and have commented, then how would I get to know that you have actually done the homework, right? You need to comment over there in the comment section that yes, this was the answer to the previous question, right? And now to all the students who are thinking that, ma'am, what are these questions? Okay, let us see. Let us see. So that was your first homework question. I gave you 2 homework questions. That was your first homework question. That was Henry's law at constant temperature states that. Henry's law at constant temperature state that. Yes, yes, everybody. What it states? The solubility of the gas in liquid is directly proportional to partial pressure. Mole fraction, yes, solubility is directly proportional to the partial pressure. It states that. Mole fraction in solution is proportional to partial pressure, yes. Then partial pressure of gas in vapor phase is proportional to mole fraction of gas in solution, right? So all of these are same things only. That means all of these are correct. That means D will be the correct answer, because this is stating the same thing, that you have partial pressure. It is equals to KH into mole fraction. And here we talk about the mole fraction in the vapor phase, not in the liquid phase, right? Okay, so that's it. Now let us see the next question here. That is the mole fraction of NaCl in a solution containing 1 mole of NaCl in this much gram of water. Now they are asking you to calculate the mole fraction here. What was the mole fraction? Number of moles of that component divided by total number of moles. Okay. So let's see how many of you, most of you have answered it correctly only. The mole fraction of NaCl. Now NaCl means 23 plus. What is the molar mass of NaCl? Molar mass of NaCl is 23 plus 35.5. That is 23 plus 35.5. That is going to be 58.5. So you can write it here 58.5. That is the mole fraction. Right? Mole fraction of this in a solution containing 1 mole of NaCl. Array, mole of NaCl is only given to you. 1 mole of NaCl is 1 mole. You don't need to calculate this thing, right? And number of moles of water will be, given mass of water is 1000 divided by molar mass is 18. So here answer is going to be very simple, right? That is mole fraction of NaCl is going to be 1 by 1 plus 1000 divided by 18, right? And you guys have already solved it. So I'm very, very, very happy about it, right? That most of you have solved it correctly here, right? You can see the answers here, right? E, okay, all of D is all of this. Okay, 1 you have answered. First one you have answered, right? Answer is here. I'm just looking here after calculation. What is the answer you got, right? Most of you are answering it correct only. Homework number 2, 1 into this. Very good. 1 divided by 1 plus 55.55. Very good. Very good. Very good. So most of you have answered it correctly only, right? Okay. So that means this answer also you got it right. Okay. Yes. Okay, everybody. Yes, students. Yes, 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 everybody. Chal. Great. Now, in today's lecture, till yesterday, till the last lecture, we did Raoult's law. Okay. So from now we are going to talk about ideal, non-ideal equations, not equation, ideal, non-ideal solutions, right? What is positive deviation, negative deviation, what is azeotropic mixture, all of these we are going to talk about. And this is a very, very important topic, and short, one question, if they ask you, let's say 2 or 3 questions from solution chapter, one question will definitely from this topic, right? This is that important, right? At this point, question on positive, negative deviation or azeotropes is what they ask you the most, right? Even theoretical questions based on that, right? Now, let us start with this. Everybody. First is ideal solutions, okay? First is, what are ideal solutions? Ideal person who follows every law, every rule, right? He's like, okay, this is the traffic signal, I will, follow this rule. Here, this is green light, I will follow this rule, right? Every rule they follow, they are called ideal persons, right? And then what can be ideal solution? Ideal solution is the one which is going to follow a law called Raoult's law. What was a Raoult's law? Raoult's law stated that the partial pressure of total, or you can say total pressure, is equals to P naught A mole fraction of A plus P naught B mole fraction of B. That means the total pressure is the sum of partial pressure of A and B when they are in the mixture. Okay. Total pressure is the summation of partial pressure, that is P naught A mole fraction of A, partial pressure of B, that is P naught B mole fraction of B. The summation of that when they are in the partial pressure means when they are in the mixture state. When you mix A and B, then what is the pressure of B? What is the pressure of B? That is the partial pressure. So total pressure is equals to partial pressure of A, partial pressure of B, that is called the total pressure. If these two things are equal, that means total pressure is equals to partial pressure of A plus partial pressure of B. In that case, we can say it is following Raoult's law, right? That means if on the entire range of temperature, the solution which obeys Raoult's law over entire range of concentrations are known as ideal solutions. And in this, why it is so? See, simple thing is, okay, let me tell you one thing. Okay, let me ask you one thing, right? That will be applicable. You will see the live example here. Live example will be there in the chats, right? What is a live example? See, just imagine that you are sitting alone, right? And you are studying, right? Just like you had this, okay? Just like you had this, wait a minute. We had a blank page. Wait a minute, let me just have that so that, okay. So let's see this here. Okay. Students, let's see. You have A. Here you have only A. And in this beaker B, you have only B. Okay. In this beaker B, you have only B. It's like you and your friend. This is you, this is your friend. When you're sitting alone, there is no one around you. You're just sitting alone, you're studying. You have more concentration, right? Your friend is also there sitting alone, no distraction, nothing, no mobile phone, nothing. Full concentration is there, right? Now, you mix both of them together. You're like, now we'll mix both of them together. And in this beaker, you will have B and you will have A. And what I am saying, here you had A and A. Here you had B and B. Right? Now, let's imagine that when you were sitting alone, right? Even then your concentration was like you got 100 out of 100 marks. And your friend was sitting alone. He was also getting, let's say, 80 out of 100 marks. Right? Now, when you're sitting together, even then you are getting 100 out of 100 and he is getting 80 out of 100. That means when you're sitting alone or when you're sitting together, you are not interacting with each other. That means you can say the interactions are same only. It's not like your way of study has changed. You are getting the same marks here, right? Same applies to the ideal solutions, right? Ideal solutions are like, when I am alone also, I'll get the same marks. When I am with my friend also, I'll be that much concentrated on the chapters, right? It's like ideal solution is like some students out there who are chit-chatting with each other, right? They are non-ideal solutions, right? They're distracting, like, they're themselves getting distracted by seeing each other chats, right? And they're talking to each other, this and that they're talking about, right? But there are some students also who are totally focused on the studies, right? That, okay, ma'am is teaching, let me just gain the knowledge out of it, right? If I be like, okay, you sit alone, right? Then also they'll be full concentrated. Now they're on the YouTube channel, they are seeing other students gossiping with each other, but they are fully concentrated on the studies, right? That means they are ideal solutions, they are ideal students. To them, it doesn't matter, right? Same is with this ideal solution. To this ideal solution, it doesn't matter the interactions of AA, the interaction of BB, and the interaction of AB are going to be same only, right? The amount of study that you are doing alone, the same amount of study you are doing when you are in a group, right? Very rare case. Isn't it an ideal situation, right? When you are studying alone, you are studying like to next level, right? But when you're in a group study, you are like, oh, I don't want to study, right? You're gossiping with each other, this and that stuff you're talking about. But here, these are ideal solutions. That's why their interactions are same. They will study on the same level. So interactions of AA, BB and AB are equal to each other. They are called the ideal solutions, right? Now, in these ideal solutions, if you see, delta H mixing, that means change in enthalpy, will be 0. Delta V mixing, that means change in volume, is also going to be 0 here, right? So we can say that the volume of the solution would be equal to sum of volume of these two components. That means if I say 100 volume you have added and 200 volume you have added, in an ideal solution where the interactions are same, then delta, then that means you can say here total volume will be 100 and 200, right? It's not like volume is going to change here. It's not like when you mix them together, there will be some chemical reaction or some interaction that they will change their volume. This will not going to happen. That's why delta V, the change in volume means volume when they have mixed together, right? They are not interacting with each other. That means there is no sudden change in volume, right? You add 100 plus 200, you get 300, right? It's not like the volume will suddenly increase or decrease. This will not happen here, right? So that's why we say delta V mixing is going to be 0. Change in volume because of mixing is going to be 0. Change in enthalpy because of mixing is going to be 0. Now, one question that is asked here, ma'am, is delta G mixing is also going to be 0? Ma'am, delta S mixing is also going to be 0 or not? Right? Delta G mixing and delta S mixing. Let us see who is going to tell me that. Students, see, delta G mixing. This is called Gibbs free enthalpy. Gibbs free enthalpy. You have studied this in thermodynamics, right? Gibbs free enthalpy for a spontaneous reaction. If you want that reaction to happen, spontaneous means something that does not need any initiation. It is occurring by itself only, right? So delta G mixing for a spontaneous reaction is always going to be negative. It doesn't matter. It's an ideal solution. It's a non-ideal solution. Delta G mixing is always going to be negative if you are thinking that this reaction is going to happen, right? Now, what is delta S mixing? Now, this, students, we have learned it from thermodynamics, that is called entropy, right? Entropy, randomness. Randomness means things are here and there. So, delta S mixing, that means entropy is always going to increase. Always, entropy of this universe is always increasing and increasing. That's why delta S mixing for ideal, non-ideal, any solution is going to be always positive here. This is always the case, right? This is always the case. Okay, students? Got it? Delta H, delta V mixing is 0, delta G is negative, delta S is positive, right? Now, let us see the examples. Now, so in the examples, what you will see, either they will be homologues. Homologues means they will have the difference of 1CH4, right? 1CH2 difference will be there. Like you have N-hexane heptane. Here you have 6 carbon, here you have 7 carbons. Otherwise, they are belonging to the same functional group. They have the difference in number of carbon by 1, right? So that is your homologues, right? Or they will be different in the substituent, and that substituent, different substituent, and that substituent will also belong to the same group. For example, you have bromoethane or you have chloroethane. The difference is only bromine and chlorine, right? They are belonging to the same group. That's why the difference is not that much, right? Or you can say this benzene and toluene. What is benzene? This is called benzene. If you see, this is called benzene and this is called toluene. These are the some of the very, very famous examples. This is called toluene. So again, there is difference of one CH2 group. This is also the homologue, right? Okay. We can't say exactly the homologue, but actually there is a difference of only 1 carbon and 2 hydrogens here, right? So that is also the ideal situation, ideal solution, right? Okay. Now, let us see. The graph will be same as Raoult's law. We discussed it, right? Now, let us see. This is your JEE Advanced 2013 question, right? JEE Advanced question, guys, I am picking. Okay, that will be, notes will be added in the description box only. Okay, your description box, you click on that, you will get the notes. Okay, let us see who is going to answer this question, guys. Where is the interaction, huh? I praised you today, so interaction is 0, or you are understanding it too much. Okay, if you're understanding, then you, if you are like, ma'am, I don't want to type when I'm understanding, that's fine. But when I ask you the question, then I want you guys to answer it. Okay, whenever I ask you the questions, I want you guys to answer it. That will be on the board only, just the way we are teaching you right now, na? Same way. It will be a board and we'll be teaching on the board only, right? In the Sigma batch, we'll be teaching on the board only. There is no iPad, or we are not teaching through pen tab or iPad. We are teaching through this board only, right? Okay, yes. Answer, ma'am, B is correct, ma'am. B, ma'am, B and D. Okay. B and D are correct. B, D. So most of you are answering B and D are correct. Let's see that. Benzene and naphthalene forms an ideal solution at the room temperature. For this process, the true statements are delta G of the system is positive. That is incorrect. Delta G cannot be positive. It should be negative. Delta S of the system is positive. That is correct. Delta H of the system, that is also correct. Now that means B and D you are answering right. But you know what? This is also correct. Acha, how many of you are weak in? If you are strong in thermodynamics, right? Here they have, you know, this is JEE Advanced question. So there will be mixture of solution with little bit thermodynamics is there, right? So this from thermodynamics, we know that delta S of the surrounding is going to be 0, especially for ideal solution. Delta S of the system is going to be positive, but delta S of the surroundings is going to be 0, right? So this is also correct here. So answer will be B, C and D is the correct answer here. Okay. Yes, everybody, B, C and D is the correct answer here. You can see it from an ideal solution. This is 0, right? Delta G is negative, less than 0. Delta of system is positive, right? So you can say B, C and D is the correct answer here. Clear to everybody? JEE Advanced 2013 question it is. JEE Advanced 2013 question. Okay, got it? Now let's talk about non-ideal solution. Non-ideal solution, right? Can you see some students in the chat box who are not like don't want to study only, right? Or they want to study, they came here to study only, but they are getting distracted again and again, right? So now for these kind of students, they are non-ideal students. Why they are non-ideal students? Because they are interacting with each other, right? Okay, so because of those interactions, right, the solution is going distracted, right? They are not able to focus on the studies, right? So same here, ma'am, how can a solution can interact with each other? So simple thing is, here you had this A, right? This was the solution, right? This was the A solution. This was the B solution. This was B solution. Okay. Now you are making a new solution here, that is A plus B. That is A plus it is B. Plus it is B. Now what has happened here? Just imagine you are like studying. Your friend is also studying. Now two cases are possible. Let me know in the chat box if two cases are possible or there are more cases also possible. Two cases are possible, that this is Chintu, right? And this is Mintu, right? This is Mintu. Now tell me one thing, when Chintu and Mintu are studying alone, right? When they are studying alone, they are very, very happy. They're like, okay, I'm able to focus, I'm able to solve this question. Yes, yippee. But now what happened? I was like, both of you sit together in a room, right? Now they are in the, right? Now what can happen here? Two things can happen here. One is they are gossiping. They are best buddies, no? They are gossiping. You know about this person, you know about this girl, you know about this guy, you know about this couple out there, right? They're gossiping with each other, right? They're very happy. They forgot about studies only. They're gossiping with each other. This kind of group study they are doing. Another kind of group study can be they are genuinely more focused. They are genuinely more focused, right? They are like very caring towards each other, right? Chintu is like, hey Mintu, have you solved this question? Mintu will like, no, I was not able to solve this. Chintu will like, don't worry, I'll teach you this. Then Mintu asks, have you solved this question? He's like, no, I was not able to solve it. Arey, I'll teach you this question now. So they are helping each other to study. Two cases are possible. One is they are gossiping, other is they are like helping each other to study more. They are actually genuinely being teachers to each other, right? Two cases. Now tell me one thing, in which case they will be more benefited? When they are gossiping with each other, they will get more marks or less marks? When you're gossiping with each other, you are not focusing on what Diksha ma'am is telling you, right? You're thinking this and that, you're talking to each other about this stuff, that stuff, which is not even related to ideal solutions. Tell me what will happen. You'll get less marks, right? There will be negative deviation. Negative deviation, right? Now tell me, negative deviation means, you can also write it as less marks. Just write it as less marks. You will get less marks. Now, when you are like, okay, when you are like, when you are more focused, right? You are helping each other. That means there will be more marks, more marks. In this case, you are not gossiping, you are focused on your studies. Okay, now I'll relate it to you. Same in the case of non-ideal solutions, right? What happens when you mix two solutions, right? Either they can be more focused, right? They will get more marks or they will get less marks. Same is with ideal, non-ideal solutions. What can happen here? Either they can gossip with each other. That means their interactions will be more. That means AB interactions are going to be more, right? When the interactions are more, that means they're going to get less marks. Less marks means towards the negative deviation. They have negative things. Negative things means they are not in the right direction. They are in the negative direction, right? Now, if you see this, when they are more focused, what will happen? They will be more focused means when you're like, okay, I'm solving this question. That means you are not interacting with each other. The AB interactions are less in this case. And in this case, it is positive deviation. And this is a very, very important point which I have seen students usually doing mistakes here. Reason being, ma'am, because we are not able to understand, ma'am, where the interactions will be more, where the interactions will be less. Just relate it to your life only, that interactions, negative deviation is when you will be negative, when you will have less marks, when you are gossiping with your friends more, right? That means interactions are more, negative deviation. When the interactions with your friends are less, you will have positive deviation. You are not wasting your time, right? Interactions are less, that will be positive deviation, right? Okay, in the end, I will tell you what is azeotropic mixture, okay? Yes, because azeotropic mixture you can only understand once you understand positive and negative deviation. Firstly, let me know if this thing is clear to everybody. What is positive deviation? What is negative deviation based on the interactions? Based on just on the interactions. I am not talking about Raoult's law, nothing. That we will deep dive into. For this, now just understand two things are possible. One is negative deviation, other is positive deviation. Right? Now, if you see, okay, now got it now, beta? Everybody, beta, if you don't answer me, then how can I tell? Tell me. Should I just end the class? Tell me. Should I just end the class and stop teaching? Because that's not how I can teach. Then I am happy teaching on Sigma batch only. Right? This is what I don't like about YouTube and like more about batch is that I don't have to ask the students. There are always ideal solutions only, ideal students sitting in the batch. Why? Because then I don't have to ask again and again, are you able to understand this and that? Totally focused. So you also have to be totally focused. No, why I'm asking you again and again? We want the class, then you have to be fully focused here. I don't want you guys to interact with each other, but just answer me that whenever I ask you the question, whenever I ask you if you're able to understand this, you have to tell me, right? Otherwise, it will be a very robotic study. Otherwise, I'll make my own AI and that AI will teach you, right? Because AI will do this work only, na? Without any emotions, AI going to teach you. Then what is the difference between Diksha ma'am and Diksha ma'am's AI? Difference is that Diksha ma'am will care for you. Diksha ma'am has emotions. Like she's like, okay, are my students able to understand? A is like, okay, this is my task, this is done or not, I don't care, right? All I have to do is deliver, right? Okay. So don't make me an AI. I am a human only, guys. Okay. So that was more negative, less positive deviation. Now let us see based on Raoult's law what you have. When a solution does not obey Raoult's law, that is called non-ideal solution. And in a non-ideal solution, you have two things. One is positive deviation, other is negative deviation. One is positive deviation, other is negative deviation. In the positive deviations, the vapor pressure, right? Why it is called positive deviation? It is called positive deviation because the total vapor pressure is greater than vapor pressure of A and vapor pressure of B. Right? Total pressure is greater than vapor pressure of A and vapor pressure of B. But in case of negative deviation, total pressure is less than vapor pressure of A and vapor pressure of B. Now understand this thing with the help of what I told you. See, I told you in positive deviation, there will be less interaction. This I told you, less interactions. Let's try to understand this. In this, there will be more interactions. More interactions. Okay, tell me one thing. Okay, tell me one thing. You are in a room, right? And I ask you all to dance with holding each other's hands and jump, 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 jump. You have to jump and touch that floor, right? So not floor, you have to touch that ceiling, right? Okay, this is what I'm asking you. All the students are in the class and I'm asking them to touch the ceiling, right? If let's say you are free, your hand is free, you can easily touch the ceiling, right? If I say that your hands, take the hand of your next friend, take the hand of your next friend, right? You are holding each other's hand and now you have to jump and touch the ceiling. Will it be possible for you? Will it be possible for you? Isn't it difficult for you, no? Ma'am, why? Because we are interacting. So when your interactions are more, when you have more interactions, what happens? A molecule who is in the liquid phase, who wants to jump out and wants to be in the vapor phase. Because now the interactions are more, he is not able to get out, right? He is not able to get out. But let's say someone who has less interactions, I am saying you, let's say I made a group there and these students are individual, right? The group students will not be able to touch the ceiling. That means they won't be able to make the vapors. That's why their pressure will decrease. But in this case, because they have less interactions, right? They are not holding each other's hand. So that's why it will be very easy for them to touch the ceiling. That means in this case, when you don't have interaction, there is no hydrogen bonding between the molecule, there is no dipole-dipole interaction between the molecule. What will happen? The molecule is free to get converted to vapor. That's why vapor pressure, total vapor pressure will be more than that is expected, right? But here total vapor pressure will be less because now the molecules have strong interactions with each other and they are not able to evaporate and get converted into the vapor phase. Okay, is that thing clear to everybody here? That what I am telling you, I have right now told you three things. One is interactions, other is the pressure, and third is the positive deviation. So these are the 3 points on which they ask you the questions. In the positive deviation, interactions are less. That's why vapor pressure is more, and that's why it is called positive deviation. When you have less interaction, it can easily touch the ceiling. That's why vapor pressure is more. That's why it is called positive deviation. But in negative deviation, it is completely the opposite, right? Okay. So Ravna, I'll take stoichiometry, but I'll take that in class 11th session. That is at 6 p.m. Right? So if you want to see that in detail, then go through that. Then I'll update you on the Telegram channel as well. Right? When I'm going to take stoichiometry. Right? Maybe next 1 or 2 weeks. Right? Okay. Now let us see next thing here. That is escaping tendency of molecules. Can you tell me? What is this I was telling you? Touch the ceiling, touch the ceiling. That was an escaping tendency, right? So escaping tendency is when a molecule wants to convert, wants to escape and wants to convert into a different phase. That is called escaping tendency. So the tendency of substance to leave its current thermodynamic state, be it solid, liquid or gas, and transition to another state. Like here we are talking about liquids who wants to get converted to vapors, right? When I'm asking you to touch the ceiling, those whose hands are free, right? They will be able to touch the ceiling. That means those who have less interaction, they will be able to easily vaporize, right? Okay. Now let us see. Positive deviation, the interactions, as I told you, interactions, AB interactions are less, okay? Less interaction, that's why vapor pressure will be more. So AB interactions are less as compared to AA or BB interaction. But in negative deviation, right? So firstly, let's discuss this only. But with negative deviation, it is completely the opposite. Let's firstly discuss full detail of positive deviation only, right? So in positive deviation, I told you that interaction of AB is less, right? Why interaction of AB is less? Everybody in the comment section. Why AB interaction is less? Tell me. AB interaction is less. Can you tell me the reason? AB interaction is less. Can you tell me the reason behind that? See, because AB interaction is less here, right? Because they are not forming hydrogen bond or any strong bonding is not there between these two molecules. That is the reason. That is the reason molecule of AA or BB, right, will find it easier to escape than the pure state. That is why there is an increase in the vapor pressure. Okay, got it? No? AA, they were like, oh my god, strong interaction. Suddenly the interactions will lessen up. It's just the same that you have your parents, right? Let's say you have your parents and they are very strict. Okay. So let's say one day your parents will be like completely chill. So you want to vaporize, na? At that point, your parents will be like, okay, you can go out, no worries. You want to chill. You're like, okay, oh my God, my parents are awesome. Right? My parents are completely chill. So let's hang out with my friends, right? So this is what happens in reality. Same is happening with these molecules, right? So when AB interactions are less, right? When the parents are not so strict, right? Then these interactions are less. They want to vaporize. There is increase in the vapor pressure, right? Okay, yes, weak bond and this, right? Now total pressure will be greater than, because what I told you, PT is greater than PA plus PB, and what is that? PT total pressure is greater than P naught A mole fraction of A plus P naught B mole fraction of B. Okay, now let us see the graph here, right? As I told you, total vapor pressure will increase. Vapor pressure, this was, if you remember, this was your ideal situation. This was ideal, this was ideal, this was the ideal graph. So the non-ideal graph will be vapor pressure will increase here, right? Vapor pressure will increase here. So vapor pressure will be, it will increase, it will increase, and it will increase, right? So vapor pressure is increasing, and that's how you draw the graph of vapor pressure, pressure and mole fraction, right, for a positive deviation, right? Now, what are the main, what about the main lines of this? That is delta H mixing is greater than 0 because pressure is greater than 0, delta H mixing is greater. Delta V mixing is also greater than 0. But delta S mixing will always be greater than 0 and delta G mixing will always be less than 0. It doesn't matter. They are ideal solution, non-ideal solution, positive deviation, negative deviation. It doesn't matter to them. Right? Okay. Yes, everybody, toluene is one of the example of positive deviation. Very good. Ma'am, then vapor pressure is inversely proportional to interaction of molecules in the solution. Yes, you can say that. If you want to learn it that way, you can learn that. Right? Okay? Yes. So, let's see the examples. And you know what? They ask the question, they will ask you which of the following is positive deviation, which of the following is not an example of positive deviation. These kind of question is what they ask you. For that, you need to know interactions are less or more. So in all these cases, I'll tell you one trick about this to learn this thing. If you see this, whenever the hydrogen bond formation is there, that will be usually more interaction, right? And stronger and more number of hydrogen bonds should be formed. So what you will see here, you have chloroform, CHCl3, and this is water, right? Okay. So what will happen here? Earlier water had hydrogen bonds, right? But when you will add chloroform into it, the hydrogen bonds of water will be decreased. And what you will see, because of this CCl here, that is also very electron negative. Like strong interactions will be formed with this CCl, right? And moreover, hydrogen bond will be formed further with this water, right? So what will happen here? The interactions are going to decrease here, right? Understood, no? The interactions are going to decrease here. Why so? Because earlier it had hydrogen bonds. CCl4, CCl, CHCl3, right? You had CCl, Cl. This is what you have. This is partially negative, partially negative, partially negative. It has polar, it has dipole-dipole interactions, right? So hydrogen bond is stronger than dipole-dipole interaction. You are breaking hydrogen bond and you are converting it into dipole-dipole interaction. So that means the interactions are less here, right? What about ethanol and CCl4? The same thing. Ethanol had hydrogen bonding. After adding, it will be converted to interactive bond, right? Then methanol and chloroform, same thing. Methanol also had hydrogen bonding, right? Basically, you need to see that when you're adding a compound here, the interactions, the hydrogen bond, you're breaking or you're forming more hydrogen bonds, right? Acetic acid, if you see, acetic acid is forming a dimer, right? But when you add toluene, that hydrogen bond, that dimer will break and more interactions will be there, like because benzene ring itself is polarity is there, so that's why those hydrogen bond is going to break. Acetone and ethanol. So now here what will happen? Ethanol, right, has hydrogen bond. When you add acetone, that is C double bond O, CH3, CH3. What will happen here? Again, the interactions will decrease here, right? Then methanol and water. Methanol and water. Methanol is HCH. Methanol is CH2OH, no? C2H5 and cyclohexane. This will also be hydrogen bond will decrease here in methanol and water, because water has more hydrogen bonds, right? Water, one molecule, if you see, one molecule is forming more hydrogen bonds, like 1, 2, 3, 4. These are going to decrease here. That's why interactions will decrease here. You have to visualize this thing in your head, that the interactions are decreasing or the interactions are increasing, right? Okay, students, what we wanted to recap this thing here, in positive deviation the interaction should decrease, right? So you have to focus whenever you are reading out the examples here, you should focus that the interactions are decreasing or increasing, because this had hydrogen bonding, this had hydrogen bonding, this also had hydrogen bonding. I'll just underline those who had hydrogen bonding, right? Hydrogen bonding, hydrogen, 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 hydrogen bonding in toluene. In acetic acid, it was hydrogen bonding. Ethanol. In this case, both has hydrogen bonding, but when you add methanol, the hydrogen bonding is going to decrease, right? And in this case, this had hydrogen bonding. So can you see the extent of it is decreasing, right? Okay, that's why we can say that the interactions are decreasing here. Okay, okay, got it. Now let's see non-ideal solution for negative deviation. Negative deviation means pressure is less. Pressure less means their interactions are strong. So in negative deviation, they have strong interactions with each other, right? So AB has more interaction as compared to AA or BB alone, right? And I'm talking about one component, either one component you can pick here, right? So more interactions should be there. This decreases the escaping tendency. You are holding hands with your friends. You can't touch the ceiling now, right? So that's where your escaping tendency has decreased here. For each component, this decreases the vapor pressure here. That is the reason total vapor pressure is less than P naught A and mole fraction of A plus P naught B. Mole fraction of B, you can also write it as, is less than PA plus PB. Right? Now, let us see the examples here. Let us see. Firstly, for that, we have to see the graph here. The graph of ideal situation was like this. This was the graph of ideal solution, right? But for a negative solution, what will happen? The pressure will decrease. This is the graph. This is the graph. This is the graph. This is the graph for non-ideal solution for negative deviation, right? Okay. For the negative deviation, the vapor pressure is going to decrease here. Is that clear? Now, as I told you, delta G will always be negative, delta S will always be positive. So we don't have to talk about this, right? Always it is correct. But delta H mixing in negative deviation is negative, and delta V mixing in negative deviation is negative as well. Okay, students, got it? Everybody got it or not? Everybody got it or not? Okay, students, get it now? Okay, so now let's talk about the interactions here, right? As I told you, in negative deviation, everybody tell me the interactions will be more or less. In negative deviation, the interactions will be more or less. Everybody, I want to see your comments in the chat box. The interactions in negative deviation will be more or less. Interactions will be more or less. That you have to tell me here, so that we can see the examples, we can get a clarity about this, right? We can get a clarity about this. Interactions will be more here. Very good. Interactions will increase, right? So let us see how. Okay. So now what you will see here, right? What you will see here, you will have, you will see, there will be hydrogen bonding. And what you will see here, that you will add a mixture, you will add a component which is very polar in nature. Okay. So let's say you're adding CHCl3. Okay. CHCl3 and you have methyl acetate. Because CHCl3 is polar in nature, so what will happen? The interactions will increase here, right? Then you have water and HCl here. Again, this is very polar in nature, so again interactions will increase here, the polarity will increase here, right? Again, this HNO3 with H2O, right? Because of this nitrogen here, that this is nitrogen, this is hydrogen, which also further it is going to, in fact, this also will increase the hydrogen bonding, this also will increase the hydrogen bonding here, right? These are going to increase the hydrogen bonding only. If you talk about acetic acid and pyridine, pyridine is a base, acetic acid is an acid, right? So pyridine has nitrogen here, which is which has lone pair, because it can donate the lone pair. That's why the interactions will increase further here, right? When you have phenol and aniline, let's say you have phenol here, right? That is, this is O and this is H. This is aniline. This is aniline. This is NH2, right? This nitrogen here, this hydrogen, when a hydrogen is connected to a electron negative element, right, then it will produce hydrogen bonding. So here also you will see hydrogen bonding, here also you will see hydrogen bonding. So that means extent of hydrogen bonding will further increase here, right? So that means we can say that interactions are going to be more in all these cases, right? Interactions are going to be more in all these cases. So answer is going to be all these are the examples of negative deviation here. Okay, so summarize all of this now. Non-ideal solution is positive deviation and negative deviation. Positive deviation is when total pressure is greater and here interactions are less, right? In negative deviation, interactions are more and the pressure is less, right? So here you can see a very important point. The boiling point is lower than the boiling point of both A and B. This is a very important point. Let's discuss about this thing firstly. Okay. They are saying in positive deviation, what happens? In positive deviation, pressure will increase as compared to A and B, right? Now, tell me one thing, what is pressure? What is pressure? Because we are moving towards azeotropic mixture, so we have to relate pressure with boiling point. For that, you need to understand how we can relate. Okay, tell me the definition of boiling point. Who is going to tell me the definition of boiling point? Boiling point is a fixed temperature, ma'am, where at a liquid will boil. Is it? Boiling point definition with respect to atmospheric pressure. Boiling point means you have a liquid, right? You will start heating it, right? It will produce vapors, it will produce vapors. Now, when those vapors are putting pressure on the liquid, they have vapor pressure. Now, when this vapor pressure of that liquid, of that component, is equal to the atmospheric pressure. If this is the atmospheric pressure, this is the vapor pressure. Then these two things become equal, because atmospheric pressure you can't change, that will be fixed. Now you have to increase the temperature, more vapors, more vapors, more vapors, more vapors, more vapors. At one temperature, when the vapor pressure is equal to the atmospheric pressure, that is called the boiling point. Okay, that is called the boiling point. Now, to understand things further, even colligative property, if you want to understand, right, then this thing you should be clear that how vapor pressure is related to boiling point and the atmospheric pressure. Okay, clear? When atmospheric pressure is fixed, right? When vapor pressure, we heat the liquid, heat the liquid, heat the liquid. At one point, the vapor pressure of the liquid is equal to the atmospheric pressure. That particular point is the boiling point of that component. Like for water, the boiling point is 100 degrees Celsius. Because when we heat it, it will come to a point which is 100 degrees Celsius and the vapor pressure is equal to the atmospheric pressure, right? Now, let us see this here, right? Okay. If you see this, they are saying that boiling point is lower than the boiling point of A and B. But vapor pressure has increased. Now, understand one thing. See one thing. This is atmospheric pressure, this is fixed. Okay, this is fixed. This is your vapor pressure, PT, which you were assuming that when if it follows Raoult's law, if I say it follows Raoult's law, then PT should be equals to PA plus PB, right? Now let's say this is the atmospheric pressure, this you were assuming. But now the pressure has increased. Earlier the jump was from here to here. This was the jump. Boiling point was more, right? Now the pressure has increased. Now this is the jump that it has to take. The pressure, the boiling point has decreased, right? You can also like understand it with this, that boiling point and vapor pressure are inversely proportional. If vapor pressure has increased, boiling point has decreased here. Okay. If vapor pressure has increased, boiling point has decreased here. Is this point clear to everybody here? Is this point clear to everybody regarding vapor pressure, boiling point? What is the relation between them? If we are saying in a positive deviation, vapor pressure is increasing, then why we are saying boiling point is lower than the boiling point of A and B, right? If that is clear, then let me know in the chat box, right? So that we can move further here. And also I want you guys, all the students who are watching this on recorded, and you see the efforts that I am doing for you to make you everything, to make you understand everything here. I am repeating it, I am making examples, giving you examples also here, right? I want you guys to like this session and share this session with your friends, right? So this is what we want. This is our Guru Dakshina from you, right? So let's talk about negative deviation. Here the vapor pressure has decreased because the vapor pressure has decreased. See beta, this was the vapor pressure that you were assuming. This was the atmospheric pressure. This was the boiling point that you were thinking. Now the vapor pressure has decreased. Now this is the point that you want to jump. That means boiling point has increased here. So you can say boiling point is higher than the boiling point of both A and B. Is that clear to everybody? Is that clear, students? This we have done already. Delta S and delta G will be always same. Delta S positive, delta G negative. In positive, this will be greater than 0. In negative, this will be delta H and delta will be less than 0. Right? Then these are the examples of positive and negative deviation that I have already told you. Now let's see the question here, that is, identify the mixture that shows positive deviation from Raoult's law. This is a question of JEE Mains 2024. JEE Mains 2024 question, right? What do you want to know about positive deviation? See, positive deviation. Okay, so this is the question here. I can re-explain you. Positive deviation, when you are telling me when you are getting more marks, that means in the group study you are not interacting. You are on YouTube and you are getting more marks from YouTube. How? If you are not chit-chatting with each other, that means the interactions are less. Less interactions. Positive deviation means less interactions. Less interactions means vapor pressure will be more, because I don't have, like, your hands are completely free. You can touch the ceiling. Same, liquids can also come back to the liquids can escape and they can convert it to vapors. They can be converted to vapors. So that means vapor pressure will increase, right? Vapor pressure will increase means their boiling point will decrease because vapor pressure and boiling point are inversely proportional to each other. Okay. So positive means less deviation should be there. So this is CH3 acetone, acetone, acetone is given to us. Positive deviation means less interactions. Less interaction. Now we need non-polar solvent that we can add here. This will generate, this is lone pair, right? This will be more interactions. CHCl3 and benzene. Again, it will be more interaction because this is the polarity it will have. It will generate polarity here, right? Then CHCl3 and this. This is again polar. So we can have A will be the correct answer. Yes, A will be the correct answer. That is showing you positive deviation from the Raoult's law. That means the interactions are less here. This is acetone, acetone plus CH2. That is your positive deviation. Acetone with CHCl3, that is your negative deviation. You can see this even here, right? Okay. I think this example I have not written here. Acetone with this we have not written here, right? But that you should know that here when you're adding CH2, that is the positive division, the interactions are less in this case. When I've had acetone with CHCl3, the interactions will increase here, right? So here A will be the correct answer. So answer will be A is the correct answer here, right? Okay. Now let us talk about the last topic of today, that is called azeotropes. Okay, students, let's talk about azeotropes. Let's talk about azeotropes. Everybody, okay, what do you think about azeotropes? Because right now they are asking questions based on azeotropes. Azeotropes are like, okay, tell me one thing. You have added two liquids here. Let's say you have added alcohol and you have added water, right? And you are heating it. You are heating it. You are heating it. Now both have different boiling points. Both have different boiling points. Okay. Both have different boiling points. You have added two components here. One is A, one is B. Tell me, bacha, one thing. Will they boil at same temperature? Like, because their boiling point is different, then what might happen here? Let's say its boiling point is X, this boiling point is Y. Right? So what will happen? Firstly, water will start boiling, right? After that, alcohol will start boiling, right? Because their boiling points are different, right? Let's say boiling point of X is greater, alcohol is greater, right? So we can say that firstly water will start boiling, then alcohol will boil, right? Then alcohol will boil. So that means this is generally what happens. Generally what happens that you have two liquids, right? You mix them, you mix three liquids, four liquids, whatever liquids you mix. Each liquid have their different boiling point, right? So when you start heating it, all the liquids, right, they will start boiling on their own boiling points. Let's say you have five liquids, right? One is 100 boiling point, other is 150 degree, one is 200 boiling point, then you have 250 degree, then you have 300 boiling point. So when you will reach to 100, this liquid will boil. When you will reach to 150, this liquid will boil. To 200, this liquid will boil. 250, this liquid will boil. 300, this liquid will boil. This is the general case, but you know what happens in azeotropes? You know what happens in azeotropes? Anybody? In azeotropes, when you mix two liquids, there is a point, there is a boiling point that is achieved where boiling point of all component is constant. Same or constant, or you can say constant. You are heating it, heating it, heating it. Azeotropic mixtures are they have a certain composition of alcohol you take, a certain composition of water you take, right? When you take a certain composition of it, what will happen after a certain point? What will happen? They will start boiling at the same temperature. That means they both will have the same boiling point. That is called a azeotropic mixture. When you mix two components or three components or 10 number of components, they say it's difficult, but two components only we'll talk about binary, okay? Because that is only possible, right? So when we take two components, right, we mix them together in a certain composition, they will reach a point where their boiling point will become same, right? That is called a azeotrope, right? Now, second question, that's a very, very interesting question. I can see that. Then students see this thing, that is, tell me one thing, you have a mixture. Okay? The mixture, some mole fraction is there in the liquid phase of A and of B. Some mole fraction of them is in the liquid phase. Some mole fraction of it is in the vapor phase. Some mole fraction of B is also in the vapor phase. Now they are saying in an azeotropic mixture, right? First is mole fraction of, let's say this is representing, let's say this is representing A and this is representing B and this is representing B. Okay. So first condition is that I taught you, that the boiling point of mixture is constant. The boiling point of mixture is constant. And the second important thing is that, okay, everybody tell me in the chat box, what is the symbol of mole fraction in liquid phase? That was represented by this. So mole fraction will be having same composition in liquid and vapor phase. That means they will have the same composition. Okay, everybody, firstly let me know in the chat box what is the difference in mole fraction in the liquid and the vapor phase. Everybody in the chat box. Yes, students, everybody in the chat box. Yes, very good. So, what you have to understand, azeotropics are binary mixture. Having one is, this is the mole fraction in liquid phase, this is the mole fraction in vapor phase. So, what they want to say, the same composition in liquid and vapor phase in boils at constant temperature. That means they will have the same composition, right, in the liquid phase, right? You can see mole fraction of A is equals to mole fraction of B and mole fraction of Y is equals to mole fraction of this, right? No. Liquid and this phase, na? Liquid and vapor phase, they will have same composition. Mole fraction of A will be equals to mole fraction of A in vapor phase and liquid phase. Mole fraction of B in the liquid phase is equals to mole fraction of B in the vapor phase. Okay? Mole fraction of A in the liquid phase is equals to mole fraction of A in the vapor phase. Mole fraction of B in the liquid phase is equals to mole fraction of B in the vapor phase. That means these things are also equal here, right? So you have to study this thing here. You should study this thing here. Is that clear to everybody? Is that clear to everybody? Right? What now? If you study this now this will be simple to you. Now, azeotropes are binary, means one solute, one solvent. Having binary, you can also say that two components are there, having the same composition in liquid and vapor phase and boils at constant temperature, right? Now, one student asked one question, ma'am, is this distilled? And cannot be distilled. Acha, who will tell me why they cannot be distilled? Who will tell me why they cannot be distilled by fractional distillation or cannot be distilled? Who will tell me that? Everybody? Thank you so much, Hemant. Thank you. Okay. Now tell me, students, which cannot be distilled. What is distillation? What is fractional distillation? It is when you have two components. Fractional distillation is based on basically this concept here. I'll just teach you this concept here. It is based on this concept that you have a compound here, water or ethanol, whatever solution you have here. In this solution, water will have a different boiling point, ethanol will have a different boiling point, right? Now, let's say water boils first and ethanol will boil after that. Now, what will happen? The one which is, I'm not going to write water and this, otherwise you will get stick to water and this only. Let's write that you have component A and B, right? You have component A and B. I am saying that A is more boiling point. I'll just write it here. Boiling point of A is more than boiling point of B. Firstly, you tell me one thing, which is more volatile. I am saying boiling point of A is more, which is more easily to be volatile. Which is more volatile, everybody? Beta, don't worry, I'll start with organic also. Mukesh, I'll start with organic also, don't worry. Right? Okay. Tell me, beta, which has more boiling point? Don't get confused in this thing. It's not like always two components of alcohol and water will be azeotropes only. At some fixed composition, they are azeotropes. At some certain composition, they are azeotropes. It's not like always you will mix acid, always you will mix alcohol or water, they will be azeotropes only. You have to reach that particular concentration. Let's say you have added 50%. Okay, I'll give you an example here. If you see 95.5% of alcohol and 4.5% of water, only this composition is the azeotrope. This is an azeotrope. Like you have HNO3, that is 68%, water at 32%, that is an azeotrope. If I take this as 50%, this as 50%, then it will not be an azeotrope. If I take this as 30%, this as 70%, then it will not be an azeotrope. So for two components to be an azeotrope, they need to be in certain percentage that scientists have already done, right? Okay, understood? Right? Now, here I am not fixing the composition. Let's say I am doing 50-50%. Randomly I am picking. I am just here trying to tell you the concept of distillation. When I say T is greater than TB, that means B is more volatile. More volatile. Why B is more volatile? Why B is more volatile? Volatile. Because the boiling point is less, right? So that means the ease of forming the vapors is more, right? That you should know, right? More volatile than A. Now, distillation processes, when you have A and B, when you will reach the temperature B, it will start vaporizing. Then you will take out the vapor, you will condense them, and you will take out the liquid B here, right? Then you will take it outside. Now you will reach a boiling point of A. Then you will take it here, you will condense it. Then you will take the liquid A here and you will take it out. That means distillation is a separation technique. Distillation is a separation technique. And that is dependent on which thing? Based on difference in boiling point. Difference in boiling point. But when you have this two component in a certain fixed composition, let's take an example that we take alcohol and water at this composition. Now the boiling point is fixed. Now they can't behave as, now we cannot separate them by fractional distillation. It's not possible. That's why we say that azeotropes cannot be separated. Cannot be separated by fractional distillation. By fractional distillation. Distillation. Okay, understood? Yes, everybody. What are azeotropes? Why they cannot be separated by fractional distillation? Everything is clear to everybody, right? Okay. Okay, students. That is clear to everybody. Shall I move ahead? Shall I move ahead, beta? Let me see how many likes. I think you should have crossed 50 plus likes by now. Very bad. You have not even crossed 50%. I was so thinking about 100 plus likes here, but you have not even crossed 50 plus likes. Just imagine that you give your 100%, even your scores are very good, still you don't get seat in JEE. Still you don't see, you are like AIR something, AIR 50, AIR 15, and still you don't get seat in your IIT. Well, how you will feel? Same thing, right? We do hard work, we put in efforts, right? Still we don't get any likes, any shares. That means complete, like it's like you are not appreciating the hard work, right? So when you appreciate someone's hard work, God will also appreciate your hard work, right? Okay, understand that thing. Uh, what you give others, you will also take the same thing, right? So give positive things to others, right? And when someone is doing hard work for you, do appreciate them, right? Yes. Okay. Now let us see minimum boiling and maximum boiling azeotrope. This concept I have taught you in today's class before also, but now I'll be mentioning that name, right? That is minimum and maximum boiling. Okay, I told you one thing. In positive deviation, everybody tell me what happens. Positive deviation, pressure increases or decreases? Positive deviation, pressure increases or decreases? VPT is greater than PA plus PB or more than PA plus PB? Pressure here increases, right? PT increases. And when pressure is increasing, the boiling point is decreasing, right? So boiling point is decreasing, right? So that is why we call it minimum boiling azeotrope. We have decreased the boiling point in this case. That is called minimum boiling azeotrope, right? And the example is alcohol. All the examples of positive deviation are the examples of minimum boiling azeotrope, but at a certain condition, at a certain composition. And here the composition is 95.5 and 4.5%. Right? Okay? Yes. Very good, creative, Nivi, Rehan, very good. Very good, Gokul. Okay. Maximum boiling azeotrope, that means negative deviation. In negative deviation, pressure decreases. So boiling point will increase here, right? Boiling point will increase here. So that's why it is called maximum boiling azeotrope. And it is also fixed, that is HNO3 in water, which is at 393.5 Kelvin. Now, do I need to remember this? Just remember the azeotropes that are mentioned in your NCRT, right? See, all the examples of negative deviation are maximum boiling, or the examples of positive deviation are minimum boiling, right? What you have to do is, if they ask you a certain composition and a certain boiling point, do it only the things that are mentioned in your NCRT, that is this one and this one, right? Okay. Okay. Now, let's see distillation. Now, this is going to be little bit tricky for all of you, right? So, you have to pay little bit more attention here, right, students? So, now more attention is needed from your side. Okay, everybody? Things are going to get little bit higher, right? So, you need to pay more attention here if you actually want to learn something new here, right? Okay. Let's do this. Distillation, okay, distillation. See, this is for ideal situation, I am telling you. Like when you don't have any azeotrope. I am not talking about any azeotrope here. I am talking about ideal situation here. Ideal solutions here. What will happen? Not positive, negative deviation. What is the, this is actually the graph of P naught. Now, we can draw the graph of temperature. You can also draw the graph of temperature here, right? This is between temperature and mole fraction, right? Now, if you remember between pressure and mole fraction, you draw this kind of graph. Do you remember this? Do you remember this graph from Raoult's law? You draw this kind of graph for pressure and mole fraction. Now for temperature and mole fraction, the graph that we draw is this kind of graph. You will get the two curves here, and this will mention the liquid plus vapor phase. This will tell you the liquid plus vapor phase when they are existing in liquid plus. This curve is telling you the liquid plus vapor phase. Here, they are existing in liquid plus vapor phase, right? Here they are existing in liquid phase, vapor phase, and here they are existing in liquid phase, right? Okay, this is the pure vapor phase, this is the pure liquid phase, right? Now, what actually you will see here, first you better tell me if that is clear to everybody, that which graph we are drawing here, right? Better tell me if till here it is clear. Array for 11th we have na video na, you go to the live session only, then you will see. Go to the live session, live section of this channel, you will see video on concentration terms that I took last week, right? I also took basic foundations before class 11th, right? That also I took. Go and watch those videos. I'm going to take more videos, like 6 p.m. is the slot for class 11th only, right? Acha, see one thing, as I told you, this is temperature curve, right? This is temperature curve. Then, what exactly is this? Let's say, if I just mark it here, let's say this is the mole fraction of A, that is 1. This is mole fraction of B, that is 1. Mole fraction of B here is 0. Mole fraction of A here is 0, right? If you had here pressure, the graph was something like this. When you have here pressure, the graph was something like this. Okay, but now this is not the graph that we are going to do. We are drawing the graph between temperature. So this is temperature, right? And this is also temperature here, right? Now, this is the temperature of A. This is the temperature of B. Achha, can you tell me here, this is an ideal situation. Can you tell me here which has more temperature, which is more volatile? This is when we are doing the distillation. One has more temperature, one has less temperature, right? So let's say the temperature of A is less here. This is the boiling point basically. The temperature of boiling point of A is less, boiling point of B is less. Or you can also write it here instead of temperature. You can write it here boiling point, okay? Boiling point of A, this is boiling point of B. This is boiling point of B, right? So boiling point of A is less, that means A is more volatile. A is more volatile. Okay? So what we are doing here, as we increase the mole fraction, the boiling point, and here this kind of curve is what you will see, right? Like there we got a straight line, here we will see a curve here, right? But one more thing, what you will see, that this is mentioning, this is giving us the vapor phase. This is where you have vapors, and this is where you have liquid. This is where you have liquid. That is the graph of Raoult's law only, but this you must have seen very rare, right? So this is the temperature and mole fraction graph. This is not the pressure and mole fraction graph. Right? This is when we are discussing about distillation is there, for an ideal solution it is there. Then this kind of graph is what you will see. Okay. Now, I'll change it to minimum boiling isotrope, that is positive deviation. Minimum boiling azeotrope, right? That is the graph of positive deviation. And this is the graph of, wait a minute, I think, wait a minute. Okay, two graphs we are discussing now here. One is the graph of minimum boiling azeotrope for pressure and mole fraction. Okay? For pressure and mole fraction, what is happening? Achha, tell me one thing. In minimum boiling azeotrope, in positive deviation, what was happening? Pressure was increasing. Pressure was increasing, right? So you have here, this is your liquid and this is the vapor phase of that liquid, right? This is the liquid, this is the vapor phase of that liquid, right? Okay. Wait a minute. I think here, this was the, let's do it this way only. Yes. Now, if you see this here, this is the pressure. Okay? This is pressure versus mole fraction graph. Okay. Now, in this pressure versus mole fraction graph, what you have seen that what is happening here, the pressure is increasing. So, can you see that the pressure is on the increasing side only, right? They will reach to maximum, this will reach to maximum, this will reach to maximum. That is the pressure that is representing your azeotrope. This point is representing the azeotrope. This particular point is where you have the formation of azeotrope. Where the pressure is more, right? Here, this pressure has increased, this pressure has increased, and this is the point where they have a fixed pressure, and at that point, they have a fixed boiling point. This I am talking about that pressure. Let's say, beta, if I'm telling that the boiling point is fixed. Okay, this is the temperature, atmospheric pressure. This boiling point is fixed to this point. If boiling point is fixed, then the pressure will also be fixed. Here I am telling you the graph of pressure and mole fraction, where you increase the pressure, and this is the point where azeotrope is formed. Right? Now, tell me one thing. When you increase the pressure, will the molecule will come closer or they will move away? Molecule will come closer. That's why when you are making pressure and mole fraction graph, this is liquid and this is vapor. This is liquid and this is vapor. And in between, they are living in liquid and vapor phase both. In between liquid and vapor phase, in between liquid and vapor phase both. Got it, beta? Everybody, let me know in the chat box if this thing is clear to everybody. What we are discussing, pressure and mole fraction graph, right? Two graphs are there, pressure and mole fraction, temperature and mole fraction, right? You discuss the graph there, right, in the Raoult's law. But now if I am saying that they have also formed a, but now if I am saying that they have formed a fixed temperature here, sorry, they have formed a fixed temperature, fixed boiling point here, then that boiling point is somewhat here. That boiling point is this point. This is the boiling point that we have here, isn't it? This is the boiling point that we have here. This boiling point is where you have, this is the, to that fixed boiling point, there is fixed pressure, and this is that fixed pressure where you have the formation of the azeotrope when you mix two components at a certain composition, right? Achha. Now, I'll just represent, this is your azeotropic mixture. Temperature and mole fraction. So, better tell me, as you increase the temperature, molecules will move away. That means they will be converted to vapor phase. That's why opposite is there. This is vapor phase. This is liquid phase. This is vapor phase. This is liquid phase. Here you have, in between the curve, you have vapor plus liquid. In between the curve, you have vapor plus liquid. Okay. I told you that minimum boiling azeotrope means boiling point will decrease. Boiling point will decrease. Can you see here boiling point is decreasing? Here boiling point is decreasing. And they are decreasing that this is the point of formation of azeotrope. This is the point of formation of azeotrope. That is your minimum boiling azeotrope. Clear everybody? That is your minimum boiling azeotrope. They will not ask you that much. They can give you the graph and ask you which of the following is maximum boiling azeotrope, minimum boiling azeotrope. And this also I'm telling you for JEE Advanced, right? Okay, in JEE Main, so they don't ask these questions, right? Azeotrope, regarding azeotrope, they will ask you maximum is examples of azeotrope, but graph of azeotrope very rarely, but still you should do this, right? Because no chance we can take. Now, maximum boiling azeotrope means negative deviation. Negative deviation means pressure will decrease or increase. Pressure, negative deviation. Pressure will increase or decrease. Everybody tell me that. Pressure will decrease. No? Boiling point is increasing, so pressure will decrease. Right? Pressure will decrease in a negative deviation. You are not interacting, negative deviation. Sorry, you are interacting more with each other. Pressure is decreasing. Right? Pressure decreases how? This is the pressure, it will decrease. This is the pressure, it will decrease. And they will decrease to a certain point where there will be a fixed pressure which is equal to boiling point. Sorry, equal to this particular pressure here is equal to the atmospheric pressure, and for this liquid and this liquid it is coming out to be the same. That's why we are saying this is the point where azeotrope is formed, that is maximum boiling azeotrope. Now we will study about maximum boiling azeotrope for temperature and mole fraction graph. This is temperature C. Maximum boiling azeotrope means what? Pressure is decreasing, boiling point will increase, right? Boiling point will increase. So here boiling point is increasing, and to one point what will happen? They will have a fixed boiling point, fixed composition, sorry, not fixed composition of liquid and vapor phase, and fixed boiling point for both the components, right? So that means there will be boiling point of that mixture, and that is going to be the maximum boiling point. That has increased. Okay, everybody? Yes, everybody? Any problem in these graphs? Any problem in these graphs? Now we are going to do some questions here. Yes, 2-3 questions we are going to do. Then you will have, I'll give you some homework. I'll give you one homework for your next class, so that I can also know that you also do your homework, right? Let's do this. Ma'am, when the class will end? Maybe in 10 minutes, okay? Let's do this. This question from your NCERT, let's do this. Heptane and octane form an ideal solution at 3. They form an ideal solution. That means they follow Raoult's law. The vapor pressure of 2 liquid components are this and this. Vapor pressure of 2 liquid components are this and this respectively. What will be the vapor pressure of a mixture? That means pure components is given to you. This is P naught A. This is P naught B, right? What will be the vapor pressure of mixture of this gram of heptane and this gram of octane? Beta C. PT is equal to, it is an ideal solution, PA plus PB, right? What is PA? P naught A, mole fraction of A plus P naught B, mole fraction of B. P naught A is given, P naught B is given to you, right? P naught A, P naught B is given to you. Mole fraction of AB you can easily calculate. Mole fraction of A, that is heptane, is going to be 26 gram divided by the molar mass of heptane, right? Mole fraction of B will be 1 minus mole fraction of A. What is the molar mass of heptane? Heptane is C7, 7 to 14, 15, 16. What is the molar mass here, everybody? What is the molar mass of heptane? Everybody, molar mass of heptane. Let's see this here. Wait a minute. Okay, I'll directly see this here only to, save the time here. Mole fraction, molecular mass will be 7 into 12, 16 into, why 16? 16 only I have written, okay. Okay, 100 it will be, so it will be 26 by 100, that is 0.26. This will be 1 minus 0.26. Put in the values of mole fraction, put in the values of P naught A, P naught B, and you will get your answer of PT here. Okay, put in the values of P naught A, P naught B here, put in the values of mole fraction of A and B here, and you will get your answer here. Okay, Simple questions, students, simple questions, right? Okay, wait a minute. In hurry, I have done one mistake here. This is number of moles, this is number of moles of B. Number of moles of B will be equals to, octane is what? Octane is molar mass is 114, right? Here it is given to be 35 grams. This will be your octane, and a mole fraction of A will be 26, that is 0.26 divided by 0.26 plus 35 by 114, and then mole fraction of B will be 1 minus mole fraction of A. Most of it is calculation only, right? Mole fraction of A you calculate, mole fraction of B you calculate, put it here, P naught A, P naught B you know, and you will get the answer here, right? Okay. Okay, students. Okay. Next is JEE Mains 2025 question, everybody. Which of the following binary mixture does not show behavior of minimum boiling azeotrope? Minimum boiling azeotrope means pressure has increased. That means we are talking about positive deviation. They are saying that which of the following will not show behavior of positive deviation. You have to tick which of the following are showing positive deviation here. Then you have to tick which of the following is not showing. That means you have to tick either ideal or negative deviation. Either ideal or negative deviations you have to tick. Okay? Ideal or negative deviation. In negative deviation, what happens? Interactions, acha see. In positive deviation, interactions are more or less, interactions are more. So you have to find something which is having less interactions. Less interactions you have to find. Less interactions you have to find. Okay, alcohol and pyridine. Less interactions are there. They are saying not show positive deviation. Positive deviation means the one which is positive deviation when, acha, wait a minute. No. Positive deviation means less deviation, less interactions. Positive deviation means when you are having positive deviation, then the interaction, wait a minute, positive deviation means less interactions will be there. That means your then answer is correct. Yes, very good. Positive deviation means interactions are less. So you have to find something which is having maximum interactions here, right? Maximum interactions you have to find. That is, you are giving absolutely the correct answer. That is this. This I have told you about phenol and aniline in the examples of negative deviation. This is showing you negative deviation, right? This is having more interaction, right? So that will be your minimum boiling azeotrope, right? So answer will be B is the correct answer here. Very good. Next is JEE Advanced 2018 question, everybody. JEE Advanced question is it? Yes, this is not for your homework. Next question I have given you for your homework. That is also JEE Advanced question. But let us see if you are able to solve that or not. 2018 question it is, everybody. Let us see that here. See, our main aim is to take you from basic to the advanced level, right? So that's why I'm also picking up questions of advanced, right? So you should know that, you know, some students, they are so scared of advanced. They are like, okay, I will not prepare for only advanced, right? But that's not our aim here, right? We want you to not get scared of advanced, right? Rather do questions from now onwards, right? Okay. So now, liquid A and B forms ideal solution. There are two liquids, A and B forms ideal solution over the entire range of composition. At temperature T, equimolar binary solution of liquid A and B has vapor pressure this. At the same temperature, a new solution of A and B have mole fraction this and this respectively. Okay, the value of this in the new solution. Okay, basically two equations you have to solve here. Okay. At temperature T, the equimolar binary solution A and B has vapor pressure this. Equimolar. Equimolar means number of moles are same. ठीक है? Number of moles are same, has vapor pressure 45 torr. At the same temperature, total vapor pressure I think they're talking about. At the same temperature, new solutions is having mole fraction this and this, respectively have vapor pressure this. So two equations we will have. First, in case Pt is given to be 45 is equals to P naught A, mole fraction of A. They are saying equimolar. Okay? If number of mole of A is equals to number of mole of B, then mole fraction of A will be 1 by 2, 0.5. That means number of moles will be 0.5, 0.5. Okay? Because that will be, if this is Na, this is going to be 2 of Na, that will cancel, it will be 0.5. No, mole fraction of A will be 0.5. So you put here 0.5, right? Plus P naught B will be also 0.5, right? That is the first equation that you will have. Okay. Now I'll just put it here. This is the first equation. Second equation is at the same temperature, new solution of A and B having mole fraction now is different. This is P naught A. This is mole fraction of A. This is P naught B. This is mole fraction of B. Now here they have given the vapor pressure to be 22.52. But now tell me one thing. You have all the things here. Can you calculate the value of mole fraction of A and mole fraction of B here from these two equations? Okay? Given that vapor pressure of pure liquid, this is also given to you. Now so we can easily calculate. Given that vapor pressure of pure liquid A is given to you. Beta, very easy now the question is. Right? Now here this is given to you. P naught A is given to you 20. Now bacha, can here you can calculate the value of, from this equation you can calculate the value of P naught B. You can put the value of P naught B here. Okay, this is also 20. You can put the value of P naught B here. Now you will have an equation which is mole fraction of A and mole fraction of B. You divide the whole by mole fraction of B, then you will get the value of mole fraction of A divided by mole fraction of B. Is that clear to everybody how you're going to solve it? You have this equation. First, you will calculate the value of P naught B. You have this equation. What is the equation? Yes. Okay. This is the equation, right? P naught A is also given to you. I would advise you to put it here. Then what you will get, the value of P naught B is going to be 70, right? This is what you will calculate from here. You solve it from this equation. From this equation, this will become what? 45 by 20 by 2 is 10. P naught B by 2, that will be the 35 is equals to P naught B multiplied by 2, that will be 70 only, na? P naught B, right? So you got the value of P naught B is equals to 70 here, right? P naught B 70. Okay? P naught B you have calculated from here, that is 70. Now you put the value of P naught B here, right? That is 70. Now you put the value of P naught B. This is the equation now what you have. This is the equation now what you have. You have to calculate the value of this here. You put this value here. Now, bacha, simple thing, we also know that either though you can divide it by P naught, but in that case you will not get it only. This was your value of mole fraction of B. Mole fraction of B is equals to 1 minus mole fraction of A. You put the full equation in the terms of mole fraction of A. Now this is the equation that you have, right? Can you calculate the value of mole fraction of A here? Yes. Can you calculate? Because only the variable is mole fraction of A. Once you know mole fraction of A, you again put it in the same equation that is here. Put the value of mole fraction of A here. Then you will get the mole fraction of B here. Then solve this full equation and you will get your answer here. Okay, ji? Everybody clear? Clear? Will you be able to solve it? Right? Okay? This is your JEE Advanced question and latest only 2018 question it is, right? So you can know that it is, yes, the calculations are not that tough, but yes, the question is even not that lengthy as compared to JEE Advanced questions, right? It is a doable question. Easily you can do it, right? Okay, yes. Now let us see, I think this is for homework. Yes, this I have given you for homework, right? This question is for homework, students. I'll just give you a hint here. The hint is liquid A and B form ideal solution of all composition for A and B at 25. Two such solution with this and this mole fraction A of A, the total vapor pressure of this and this. Wait a minute. A and B form ideal composition. Okay. Two such, that means it is following Raoult's law. Two such solution with this and this mole fraction of A, only A, okay, have the total vapor pressure of this and this bar respectively. That means when the mole fraction of A is 0.25, then the total pressure is 0.3. When the mole fraction of A is 0.50, then total pressure is 0.4. Okay, beta? This is also on the same line. What is the vapor pressure of the pure liquid B? Right? That means they are asking you the value of P naught B. Okay? Total vapor pressure. Now, beta, I have one hint I'll give you here. That mole fraction of B you can easily calculate here. B is equals to 1 minus mole fraction of A. You can calculate the value of mole fraction of B here also, right? Then put it in the formula of Raoult's law, that is Pt is equals to P naught A mole fraction of A plus P naught B mole fraction of B. You will get two equations here. You have to solve those equations. Like you get two equations with X and Y as variable now. Here the variable will be P naught A and P naught B. Those will be the variables because Pt you know, XA and XP means mole fraction of A and B you will know. This you will know, this you will know, this you will know for two equations, and from those two equations you substitute and you will get your answer. Okay, so take the screenshot here. I'll be waiting. This is the JEE Advanced 2020 question and I want you guys to solve it. Write it in the comment section that what is the answer. It will only boost your confidence that yes, I have solved JEE Advanced question, right? This is the advantage of doing questions along with the theory part, right? Otherwise, just going through the theory part will not help you, right? And do the homework yourself, right? Don't see it anywhere on the Google, net. Please don't do that, right? I have already given you enough hints here, right? Now, what you have to do is apply whatever I have told you and see, even if you are right or wrong, doesn't matter. What matters is, have you tried? If you have not even tried, you have already failed. If you have tried, that means you're already in the right direction, right? Okay. So I want to know whether you want to be a positive deviation or negative deviation. Positive deviation, or for being a positive deviation, you have to answer things, right? Okay. And students, those students who want to know more, like if you like this session, right? You are like, ma'am, we want more lectures here. Then do like this session, share this with your friends. And for more such session, you can subscribe to our Telegram channel. You can just scan this code and what you will get is directly linked to our Telegram channel where all the live sessions will be there, right? So all the notification, everything is there on this Telegram channel. And students, I want all of you to comment. I want all of you to comment your homework here, right? And those who are looking for any batch, then students, you can see this over here in the description box. You will see, firstly in the description box only, wait a minute, right? Okay. So in the description box only, you can also join it here now. If you want to join the channel, you can pay this much amount and you can join. You can be a member of this channel because I'm already the member here, so I don't need to do that, but you can do that to avail more things here, right? So that to get that X factor among the students, right? And here, if you see that in the description box, you will see here Sigma JEE Batch 2026, right? Click on this and this is our prime course which is available at 4,999. And in this, we provide you live sessions, doubt classes will be there, replays, Also, you can watch your doubts in the replays. Mock test will be taken, test series will be provided to you. After every 15 days, mock test will be taken, DPPs will be provided to you. And in this Sigma batch, students, it's not like we are just providing you these questions. We are also providing you the modules, Tattva modules, right? And you can also avail these kind of short QR cards here, right? Where you will get the short notes here, right? So different variants of the Sigma batches available to you. You can just click in here and you will get to the portal. Now, for all those students who are looking for any offline coaching, then students, let me tell you a very important thing is going on right now. That is IV SAT scholarship program. That is a scholarship program where when you register yourself to the scholarship program, you get good marks here. You can avail up to 90% scholarship, and that is available at this point only. After 1 or 2 months, it will not be available, right? So what you can do here is register yourself, visit your nearby offline center here. If you're from Bengaluru, then JP Nagar Bengaluru Center, you can just call here and ask the counselors and the teachers. You can visit the addresses given on the slide here, Vedantu Learning Center, that is Bengaluru, JP Nagar. And here, students, all over India also we are located. If you're from other state, then also you can locate your nearest Vedantu Learning Center. Why this offline center? Because why Vedantu? Because we are providing you guarantee here, guaranteed improvement or 100% fees refund. That is very rare. And also you can refer to our results here. You can refer to our results, that are excellent results we have delivered here. If you want to be one of those students, right, at this point next year, if you want me speaking about you to other juniors, right, then you should avail this opportunity, that is IV SAT scholarship program, right? Okay, yes. Okay, students, so that's it. I'll be taking your leave. Now I want you guys to comment down the homework, and definitely that makes my day when I see you guys very enthusiastic regarding the homework and very dedicated towards the lecture, right? That's what I want from you, right? Okay then, students, bye bye, take care, bye.